Today we're going to do a lab simulation in order to test for the relationships between certain variables in our centripetal force equation. You can see the problem here, always phrased in the form of a question. It says, what are the relationships between centripetal force and speed, centripetal force and radius, and centripetal force and mass? So you're actually going to do three kind of mini experiments here to find three different relationships. Now, because you're going to do three kind of mini experiments, I guess you could say, means you have three sets of variables. In each one, you're going to have one manipulated variable. And I promise you, it's going to become abundantly clear what the manipulated variable is going to be in each of the experiments. Also, the responding variable, and this time the control variables, of which there are technically many, many, many control variables, but two important ones that you have to list for each little mini experiment. They will become pretty clear to you as we go through this as well. So in part A, one manipulated variable, you're going to have one responding variable, and you're going to have two control variables that you're going to need to list. And like I said, it's going to become pretty clear to you what all those variables are as you're doing this. So part A, part B, part C, you're going to have to list all those variables. Now, you're going to collect some data, three sets of data for part A, part B, and part C. Part A, this is what your data is going to look like. You're going to actually record a mass in a radius and then 10 different speeds and 10 different centripetal forces. Notice in the data table, there are no units. You've got to record the proper units for this. Same thing for part B and part C as well. Now, how are we going to get this data? How are we going to fill in this table? Well, if you go to your Google Classroom, you're going to see a link there. You're going to click on that link, and it's going to take you to an applet that looks like this. I don't want you to press start right away. What I want you to do is first press the little button that says velocity, press the button that says acceleration, and that's going to show you the velocity and acceleration vectors. So that's not actually going to form the basis of this lab, but it is conceivably going to help us down the road on one or more questions that you might see at some point. Which way is the velocity vector always? Which way is the acceleration vector, and therefore the force vector, always pointing in this? So we don't need to necessarily record that, but make a mental note of which way those vectors are pointing, or make a physical note of which way those vectors are pointing for, not for this lab, but for down the road. Now, three experiments. The first experiment, we can see that we're going to have 10 different speeds and 10 different centripetal forces. So what we're going to do is, for the first experiment, press start. We can see that, you use the first setting that it's at if you want. You can see that my speed's at 20 meters per second. We can see that my radius is at 30 meters. My mass is at 10 kilograms. And we can see that the acceleration is given to me as 13, it says meters per second per second. That's the same thing as meters per second squared. The force doesn't really matter what the force is there. So there's your first set of data, speed and centripetal force. Sorry, we don't want the acceleration. It's the force that we want to record, speed and force. And then what you're going to do is change the speed. So change it to doesn't want to change there. It will in yours. I promise it will in yours. Well, let's try clicking it. There we go. There we go. Change it to 24 meters per second. So now my speed is different. My net force is different, or my centripetal force is different as well. It's 192 newtons. Change it again, 27 meters per second, 243 newtons, and so on and so on and so on. 10 different speeds, 10 different centripetal forces. Now remember, you also need to record the mass, which is going to stay the same, and the radius, which is going to stay the same. Just don't forget your units. Then the next experiment, that's your first little mini experiment that you're going to do. Part B, the second one that you're going to do, this time you're going to notice the mass and speed are going to stay the same, and you're going to go through this, keeping the mass and speed the same, changing the radius from one trial to the next, at least 10 times, and seeing how the centripetal force responds to that. And in the third little mini experiment, the third part of it, part C, you're going to keep the radius and the speed the same, and you're going to change the mass and see how the centripetal force responds to that. This is all up on Google Classroom and on your template as well. What you see is what you get on your template. Now, we got to do the analysis. And what we want to do for the analysis is find 3 different relationships. Now, these are the possible relationships that we could get. We say y is proportional to x. In other words, whatever happens to x happens to y. We call that a linear relationship. And if the graph we get looks like this, if it's a straight line, that's a linear relationship, right? Y is equal to mx plus b. That's a linear relationship. If the graph that we get looks like this, and you guys have done enough math now where you probably know this, if the graph that you get looks like this, then this would be a quadratic relationship. We would say y is proportional to x squared. In other words, y is equal to ax squared plus bx plus c. Remember that? Math class? So this would be a quadratic relationship if you get a graph that looks like this. If you get a graph that looks like this, then this could be an inverse relationship. In other words, it could be this one. Y is equal to 1 over x, or y is related to 1 over x. Or it could be y is related to 1 over x squared. It's pretty difficult to tell just by looking at it. Okay? So what I'm going to tell you is this. There is a way to determine it mathematically. It's just a little bit beyond the scope of Physics 20 to figure that out. So what I want to tell you is this. You look at this, it's going to be either 1 over x or 1 over x squared. I'm telling you that if you do get a graph that looks like this, then it's going to be an inverse relationship, not an inverse square relationship. That doesn't mean that down the road you couldn't get a graph that looks like this and it could be an inverse square relationship. In Physics 30, we'll learn how to determine the difference between those two when we look at that graph. But in Physics 20, like I say, that's a little bit beyond the scope of what we do in Physics 20. So if you get this, it's linear. If you get this, it's quadratic. And if you get this one, it's an inverse relationship. Although technically it could be an inverse square, it won't be. Now, this is what you actually have to do to formalize those relationships. You got to plot 3 graphs. Centripetal force versus speed, centripetal force versus radius, centripetal force versus mass. Let's see what shapes we get. Right? We know when we get this shape, it means this relationship. When we get that shape, it means that relationship. First one says, determine the relationship between the 2 variables in the graph from the choices above. Match this with the actual variables in the centripetal force equation. So, for instance, if this question was not about centripetal force versus speed, if it was about kinetic energy versus speed, okay? I want to make it kinetic energy because I don't want to give you the answer to this ahead of time. So let's pretend this lab was about kinetic energy. And you are plotting kinetic energy versus speed. You plotted that graph, part A, kinetic energy versus speed, and you got a graph that looks like this. You would say that that is we'd say that that's a quadratic relationship. Good. So we'd say y is related to x squared. And we'd say that's quadratic. And then we would match it with the actual variables in the centripetal force equation. So I would say F is related, sorry, we're not doing force, right? We're doing kinetic energy. We would say EK is related to V squared. Is EK related to V squared? EK is equal to 1/2 m V squared. You see what I mean there by matching it up with the variables in the actual equation? So write down the relationship. Y is related to x squared. It's a quadratic relationship. And then relate that to your actual variables. EK is related to V squared, or F is related to whatever the case may be in these particular ones. So do the same thing with part B, except it's force versus radius. In part C, it's force versus mass. Now, that's it. I don't even have a conclusion for this. I had a conclusion last year, actually, and then I took it out when I was adjusting this earlier today, because I'm like, it's redundant. Like, we're stating the relationships already. You're showing, we know how we found these relationships by these graphs, right? So to actually restate it as an inclusion, it just seemed a little bit redundant here. So that's it. You're going to do your data, so your variables. Your problem is already done for you. You're going to do your variables times three sets of variables. You're going to do your data times three sets of data, and you're going to do your analysis times three sets of analysis. And that's it.